This is Module 11.02, Conjugate Acid-Base Pairs and Hydrolysis Equations. We're just going to look at the conjugate acid-base pairs for now. All right, so conjugate acid-base pairs. These are chemical species who only differ by one hydrogen ion, H+. So let's take a look at this example of a conjugate acid-base pair. Notice in red, we have the acids. In blue, we have the bases. So we can see that, and I'm highlighting this for you. Hopefully you can see that. The only difference between HA and A- is that hydrogen. Likewise, the only difference between the base, or the BH and the HB, is a hydrogen. So these are conjugate acid-base pairs. Let's take a look at these in a little more detail. So here we have an acid dissociation equilibrium. One of the ways that we evaluate an acid strength is by its ability of the acid to donate a hydrogen to water. So is the water going to take a proton from the acid? So in this case, what we see happening is this hydrogen here is being donated to the water molecule to make H3O+. We form a conjugate acid-base pair between the HA and the A-. Now, if we're looking at the water is operating as a base because it's going to be accepting a proton. Now, let's look at moving the other direction. So if we're running in the reverse direction, okay, so emphasizing this, in this case, the hydrogen is being donated to the anion, and so we have an acid. So we have a conjugate acid-base pair. They only differ by the proton. Let's take a look at a base dissociation equilibrium. Base strength is determined by the ability of the base to take a proton from water. So in this case, we have ammonia, and it is going to take a proton from water. So there's our labile hydrogen, relatively labile, and we're going to form the ammonium ion. We have a conjugate acid-base pair with the ammonia and the ammonium. And we have a second conjugate acid-base pair with the water and the hydroxide. Notice again, the only difference between these conjugate acid-base pairs is the hydrogen. So the objective here is you should be able to identify conjugate acid-base pairs. So let's try this. Identifying conjugate acid-base pairs. So first of all, I'm going to look at the nitric acid, and I'm going to see if I can find something that only differs by a hydrogen. And sure enough, there's the nitrate ion. So I have an acid and a base, and I'm going to link them together. This is my conjugate acid-base pair. Now let's look at the H2O. And we're going to link that with the H3O+. And again, we have a conjugate acid-base pair. In this case, the acid is the hydronium ion, and the base is the water. So it all depends on which way you're going. Now, one of the things I want to draw to your attention is HNO3 is a strong acid. So I used a one-way arrow. This shows the reaction is virtually 100%. So it shows the reaction, I'm going to abbreviate that, is virtually 100% in the forward direction. In reality, there is an equilibrium, but it lies so far to the product side that we use a solid arrow when we're talking about the strong acids. My next example is a weak base that we're putting into water. So I have my Methylamine. I want to find something that differs only by one proton. Oh, there we go. Okay. These two are linked together. This is a base because it is accepting a proton in the forward direction, but in the reverse direction, the ammonium cation is an acid. And then we can also link together the water and the hydroxide. So we have another conjugate acid-base pair. All right, you are going to try the following. So remember, look for things that only differ by one proton. I'm going to pause the video. So let me write pause. You're going to do the first two, and then I'll put up the answers. Okay, let's check yourself and see if you got it right. For the first one, the iron hexahydrate complex is going to be picking up, giving up a hydrogen. So it's going to be your acid, and then the water is acting as a base. The second reaction, the water is again acting as a base. So make sure you understand, because I'm going to pause the video again and you are going to do the next two. So I'm going to write pause and you're going to do the next two. Okay, there's the last answer. I was wrong. There wasn't two. There was only one. So take a look. Okay, and so this is it for identifying conjugate acids and bases.